Okay, now we will demonstrate the drag and drop for everyone. This drag and drop is quite complex, so take it slowly, and there are some points worth pondering. First, we will implement the drag and drop within the inventory slot. We need to override these three methods. Let's put them here. We'll override them. Okay, so when we override them, first, when we detect a mouse button press, we first call the parent class function. Then we check the button event. Check if it is the right mouse button. Is it the right mouse button? If it is the right mouse button, regardless of the outcome, we will return a handle. First, let's prepare a handle. We might need to return it later. Yeah, we can just return it directly. So, what do we do here? So, if it is determined that this place is the right mouse button, we get it here. It creates such a widget equivalent to. Then we check whether the widget you are holding exists. If it exists, we detect the key press. Then we pass this figget and pass this event out. This function is a function inside this widget. We can take a look here. Its meaning is get this VGIT. Anyway, just get this cached VGIT. Then we go back into this handle. Return to this handle. Trigger this, that is, this slat. It has been detected as being dragged. That's the situation. Then pass this thing into it. Then pass the corresponding key into it. Then afterwards, we get to the second step here. This part is a bit more complicated. Then we first need to check whether the drag class we currently specified exists or not. Then, of course, at the end, we must call the parent class function. Okay, alright. So, when we drag, we want to display something. Therefore, this must exist. It must exist. And then this icon must also exist. And the texture that this icon points to must also exist. Then here we create a class that we want to display during dragging. Of course, this can definitely be created successfully. And then we then proceed to create a drag event. Then a drag event. This is the U-board, a drag operation. And note, this drag operation, you don't have to use this new object. You can click here, we sync it over. It should have one here, a blueprint that can create such a drag. Such a thing, let me show you. It might be hard to find, you can actually use his. It's fine. Although under the hood, it's also a new object. This is also fine. We'll just use Loo object directly. You need to think about this part. That is, whether you need to create one. Pass it using Loo. Whether you need to give it a strong reference to prevent it from being G-it. Actually, this part should be no need to give a strong reference to let it be G-G-E. Okay? Why in this part? I wrote a strong reference before. Why am I not writing it now? Well, I can tell everyone, this part is a bit deep. So here you lift an object, you need to do it this way. You need to globally search for this function. You will find that this function, it is called here. Under the hood, it is a select. It is called here. So in this place, it is equivalent to here. Pay attention to this parameter. This is a reference to a pointer. So this pointer, after you modify it, it points to this pointer. If this pointer is a 6 object, then it will be here. It will be passed to this from DragDropUp location. And this thing, it is a very deep thing. It inherits from G sub J array. G sub J array. It has a very important thing called add reference object. Here it essentially means that is, you can see, although this is a raw pointer to drag operation, but it can prevent. Through this function, it allows this thing to be, that is through it. Through such a collector, a drive operation, it's just like an ADT rule. This area of knowledge is very deep. If the interviewer wants to give you a relatively difficult question to answer, after the last few questions, he will ask you about this GC object. He won't tell you, that is, he will ask whether there is any way to prevent this object from being collected. What methods have you used? Then you must answer, GC object array, how is it used? It can help you prevent this operal from being recycled. Then during dragging, it will hide behind a knowledge point like this. So here we comment it out. We no longer need to write it this way. Okay, then we do. After we pull out this drag operation, then we need to handle this. First, we take the UMG we created for this drag. We make a copy of it. This image is definitely obtained from our slot. This is something we wrote ourselves. After we finish copying it, we put this, the UMG we want to display, put it into our drag and drop operation. Then it will be displayed at this location. And finally, we pass in some of our payload information. Pass in our payload information at this location. It tells us where it was dragged from. This payload, then pass our own URS node over. Then here at auto operation, assign this value to it. And because we are now being dragged, so we need to hide our original numbers in charts. This way, during the dragging process, we perform such an operation. Then when we finish the drag, then we have a more complex situation like this. Let's first write a simpler one. Pay attention. Okay, the return value should be fine. Then we mimic this place and give one. Whether this drag is completed, and then first we call the parent class. Call the parent class. Then by default, we have not completed this drag. Good. This way it's okay. So first of all, this thing of ours must exist. This operation is very important. If it does not exist, we cannot retrieve the data inside because we also don't know where it was dragged from. It might be dragged from the skill panel, or it might be dragged from somewhere else. At the same time, this player-controlled onActor must also exist. If it does not exist, we have no way to perform this substantive operation. Then at this point, we need to determine this complex type inside. If it is this, it can certainly be converted to this slow base, right? Right. So how do we do this here? After converting it to slow base, here in the constructor, we gave it this. So this way, we don't need to convert it again. We just directly access what type it currently is. Then we can use this switch to handle it. And we base this switch on that. Hey, it didn't auto-generate for me again. I don't know why it won't auto-generate. If it's currently a slate alone, that would be a bit strange. We generally wouldn't encounter this situation because there is no slate alone. We'll just make it display. This thing might be a bit strange. We'll just ignore it. It seems we misspelled this word here. We'll ignore that too. Then if we currently have this inventory, if we currently have this inventory, what should we do? We'll just drag it from the window library. We'll just swap it directly. But for the swap here, we have to go to the server and send an RPC to perform the swap. So the last method needs to be changed. We'll just do it like this. Okay, we can stop at this method. Then at this point, our drag is complete. And of course, let's not worry about it for now. Then here, if we are, essentially if we are coming from the equipment slot, we haven't written it yet. Let's just leave it for now. We'll just leave it empty here. And now, we need to go to our character. We need to add a method like this in the character. Let's put it in this position. Put it in this position. It is also a server function. It must be executed on the server side. Let's create its implementation. It seems there are some issues here. So, it looks like we made an error in creation. I don't know why this happened. It just jumped to that position. Let's ignore it. Okay, let's try again. If it doesn't work, we'll just paste it manually. It really didn't work. Let's ignore it. We'll paste it over. We'll just put it under this. It should be implemented here. We'll paste it over here. And we need parameters here. Let's come here and check this parameter. And note that we need to add an implantation here. And then, note the part before this. We need to copy this parameter over. Okay, now go back to our slot. Go back to our inventory slot. Then at this point we call it. It should work. Then we just need to make a simple call to these two things we dragged over. Let's compile it now. Generally, parameters in the intermediate folder. are not allowed to be modified, because every time you regenerate it, it will be overwritten. Okay, let's check this part. It seems I forgot to write a parameter here. Okay, let's compile it now. This should be fine. Okay, let's check this part. This is a warning. We'll just ignore the warning. Now let's launch it. Let's see if we can successfully complete the drag and drop functionality. This is really too slow, because having debug mode on makes it really laggy. Okay. Now, we'll just use a single client. Okay. Alright, we used one client. Then, let's press Shift, pull S, pull N, then press the right mouse button. The drag and drop has been successfully implemented. Right? And after you finish dragging, its functionality works correctly, you can see, but actually it still has some small bugs. Now, when you drag inside here, it works perfectly fine, right? But there is a problem, that is when you drag, it disappears, right? But once you use it, it becomes normal. That's because on this UMG, you didn't implement that drag. Override the drag method. Once you override it, it will be normal. Later, we'll write it for everyone. Then everyone will understand. So this is a small bug, but it's not really a bug either. For example, if you want to drop it on the ground, then here you can just release it in another drag and drop area on the UMG. Then it will generate the corresponding item in the scene. Okay, so we will implement this drag and drop functionality within the inventory. This demonstration of drag and drop is now complete. Thank you, everyone.